We've got Duncan Curd. He's the VP of Sales and Marketing for Grip Idle Management Systems in Ancaster, Ontario. Grip specializes in reducing emissions on gas and diesel-powered vehicles. Mr. Curd's career has been focused in the automotive, HVAC, and industrial automation space. He's held a variety of national and international roles serving these industries. As general manager of Nortec in Ottawa, he was responsible for greatly expanding the company's local and global sales by introducing innovative HVAC technologies that not only reduced energy costs but improved building occupant health. During his time at Siemens Canada, he managed a number of key business units that included large projects, discrete and process automation, as well as industrial communications technology. And in his spare time, he invented the internet. He has worked with Siemens USA as the global account manager to the Ford Motor Company in Detroit. So with that, let's please welcome Duncan Curd up. And now that I've introduced him, I see that we have the AQMD PowerPoint queued up. So with that, let's just introduce. Hey, Duncan, you're great, but you know what? A star like you, we need an opening act for it. We can't let you headline. Oh, okay. Well, in that case, you're going to be the opening act still.
So that was this one?
We can do this with a nice...
Nope, next one, the other one.
Like this. It's, we said we could go fully acoustic perhaps as well.
Grip idle?
Okay, that wasn't open.
That was the one that was in one of the, I think this here. Yep. Grip idling. Bingo.
And we're going to do that. And there's a clicker.
Here's the clicker.
Perfect, great, thank you. So, good morning, everybody. How many people here...
Duncan, we're going to make you use the microphone.
Okay, well, I can't go acoustic.
We have wireless, right?
Oh, there's a wireless. Okay.
That's okay, we can use the mic.
Perfect.
So how many folks know that they have an idling problem in their fleets? Show of hands. How many folks don't know if they have an idling problem? Show of hands. Okay, so probably some of you have got your idling well under control, and that's great to see. Generally speaking, going across the country, we see that there's a real lack of understanding and information around idling and the impact of idling. Pop quiz, do you know what 1 hour of idling is equal to in terms of engine wear? Anybody want to hazard a guess? Fleet managers. 100 miles, okay. 30 miles? 30 miles is the right answer. I've sat in rooms where fleet managers thought that 1 hour of idling was equal to 0 hours, or 0 miles of engine wear, if you can believe it. The closest I had in one case was 3 miles. 30 miles is pretty much the case. So if you're idling, you're putting on the equivalent of 30 miles. We call that ghost miles. And many fleet managers aren't necessarily looking at hours. They're looking strictly at the odometer reading. And of course, that doesn't then give us the predictive element to be able to avoid issues and do the necessary maintenance. So we do know that we do have to idle. Vehicles idle for a number of different reasons. One of them is to maintain onboard systems. So we have to differentiate between a vehicle that's on, electrically speaking, and performing work, versus having an engine on. And that's an important factor when we talk about how the grip operates. So for policing, we need to maintain all of the safety features, airbags, electrical equipment, computers, etc., takedown lights. If we have a work vehicle, we have a PTO, we may need to also maintain those systems, keeping those systems on. And traditionally, we do that by keeping the engine running. We may have other considerations. Right now in the north, we've got cold weather. We need to keep the cab warm. We need to stop diesel fuel from gelling and have other environmental considerations. We may have to keep, in extreme climates, that fuel warmed up. We may need to keep hydraulics warm. We may have the exact opposite. We may have temperature considerations from the higher side of things, or we may need to maintain onboard things like hydraulic pressure or air pressure, for example, to brake train cars. We talked about ports. We do a lot of work in ports. If we're moving train cars around, we're using air to release those brakes in a Westinghouse system. So the impact of idling on fleets. Right now in the US, we're looking at wasting about 6 billion gallons of gas when we're idling. That's equal to $20 billion. Those numbers, by the way, most of this comes from Argonne Labs as well as Oak Ridges, which are great resources if you want information on idling and emissions. We talked about the equivalent of 1 hour of idling typically being equal to about 33 miles of engine wear. That also equals about $2.30 per mile, per hour of maintenance cost. And you folks know what your maintenance costs are, so you can plug those numbers in. It's safe to say that for diesel, those maintenance costs tend to be higher than they are for gas because we have after-treatment systems to consider. And of course, if we look at just a typical cruiser, a Ford Interceptor, which are common in fleets, we're looking at about 0.7 gallons being burnt per hour, and we're therefore looking also at a fuel cost of around $2.70 per hour, and then finally about 20 pounds of CO2 being emitted. So those are significant numbers when we start to look at that from a fleet point of view. And any of these numbers a surprise or a shock to anybody? Because I often find people shaking their heads saying, hey, don't know if I believe that. These numbers, again, come from Argonne, and they represent what's going on in an average fleet. So when we're idling, we have a number of impacts. We have the direct cost of fuel. That also represents then a direct output in terms of emissions, CO2 and particulate. We then have the maintenance costs, and I've mentioned that can be very significant from a diesel point of view, but also for gasoline. We have the unexpected or unintended consequence of, let's say, failure to have adequate PMs, and therefore we may have vehicle unavailability. So we lose operational readiness. And another factor, how many of you are struggling in hiring technicians right now, in getting folks that maintain equipment? So if you can reduce the amount of maintenance that you're doing, you're also reducing the number of technicians. And by the way, that also works for vehicles. While those vehicles are in the shop, they're being maintained, they're therefore taking up time and space, you can reduce the number of vehicles in a larger fleet. And in fact, with Toronto Hydro, we reduced their fleet by 12 vehicles on the utility side, just by reducing the amount of idling. There are a number of other factors that we consider: the time it takes to refuel, the distance it takes to refuel more often, and so on. Of course, the biggest factor for California is poor air quality, and there is that direct element. So what we do with GRIP is we're really looking at taking a traditional or conventional vehicle and hybridizing it. What we do is we use the battery and an auxiliary battery typically, which can also use shore power if we need to plug in. And we're also using the heat of the engine to allow us to use that coolant to heat the engine where there's a requirement for heating. So if we look at traditional work truck applications or work vehicle applications, we can achieve as much as a 70% reduction in idling. And that can have a significant impact on a fleet. It gives us an ROI typically of between 18 months down to as much as 8 or as low as 8 months in terms of return on investment. And I think Ms. Scott pointed out that decisions you're making today as fleet managers for vehicles that may have a 15-year life are going to have an impact down the road with restrictions that are out there for 2030 or 2040 and some of the other dates that are being thrown out right now for compliance. So by reducing the unnecessary idling, we've talked about a number of different benefits. And of course, I think one of the other factors is that we're seeing a demand from some of our municipal customers that they want to extend their vehicle life. They're being asked to make do with less in terms of cost, and that means trying to extend a police vehicle by, say, 2 years. How do we do that? Well, if we're reducing the amount of idling and the amount of wear and tear by, say, 25% or 30%, we also have an equivalent increase in the life expectancy of that vehicle. We can't help you with rust, though. Rust doesn't work, but specifically for engines and the mechanical systems associated with vehicle engine on or running. So the GRIP basically, as I say, hybridizes the vehicle. We'll use the battery and we'll use an auxiliary battery to allow us to turn the engine off but keep the vehicle on. So all of the vehicle systems, airbags, restraints, radio, etc. are running. Chargers for inverters for doing work. If we have a PTO, we will have to run the engine when that PTO needs to operate, but otherwise we can ensure that the vehicle engine stays off when it's not required. So I wanted to just show a couple of examples of the grip in action. The Columbus Police Department started using the grip in 2014. You can see the quotes there. I won't read them out for you. These come from both the police chief as well as from the fleet manager, Kelly Regan. Kelly was #1 fleet manager in the U.S. in 2014. And we've helped helped Columbus significantly reduce their operational costs by implementing the technology. They're up to about 450 vehicles now with the grip running. That has represented, for the policing side, a reduction in idling of 35%, and we actually could reduce the idling that they're currently doing further if we took away some of their officers' control of the idling. In other words, we allow them to override the system in certain circumstances. In terms of savings, we've saved them about 152,000 gallons of fuel so far, and that represents about $313,000 in fuel savings, cost savings. And in terms of the engine wear, we've reduced engine wear by about 11 million miles, which again is a significant number. On the work truck side of things, moving to the diesel side, away from supervisory and other applications, Paul Chamberlain, fleet manager up in Clark Utility, they're in Portland. That's basically the Portland Energy Authority. They're running these on both diesel trucks as well as on gas-powered vehicles, and they've seen a reduction of around 25% of their costs by reducing their idling. And there's some numbers. This comes from an NTA presentation Paul did a couple of years ago. And just again to sort of validate the kinds of idling that you see in this type of aerial application, the engine wear reduction, or the amount of idling they're doing, was 82%. And I've seen fleets that in ports that might have 30 miles on the odometer and have the equivalent of 100,000 miles in terms of idling. So it becomes quite significant. Great. Well, that's the end of my presentation. I think we're taking questions at the end. Thanks for your time.